In this video, I am going to explain about worksheet questions of P block elements, that is group 15 to 18 groups. So these are important models. First question. Chlorine is allowed to react with excess of ammonia. So in this 1 mole of chlorine can oxidize Z moles of NH3. So here Z is. So it is balanced equation between excess of ammonia and Cl2. So N2 plus NH4Cl, ammonium chloride, will be formed. So clearly 8 moles of ammonia will be equal to 3 moles of Cl2. Therefore 1 mole of Cl2 is 8 by 3 moles of NH3. That is Z equal to 8 by 3. It is option B. That means 1 mole of Cl2 reacts with 8 by 3 moles of ammonia according to balanced equation. Assertion reason. So assertion is both rhombic and monoclinic sulfurs are having S8 molecules. S8 octaatomic. Next reason, they have planar structure. See here, rhombic sulfur and monoclinic sulfurs are having same S8 molecules, octaatomic, but shape, see here, cone shape, not planar, cone shape, which is puckered ring structure. Here puckered means stainless. So S8 molecule structure will be cone shape, which is puckered ring structure, that is stainless ring, highly stable. Therefore assertion correct, reason incorrect. Option C. Next, very important, the chemical structures of XeO3 and XeO4 respectively are. So XeO3, xenon trioxide. So your structure will be Xe with one lone pair and 3 double bonds with 3 oxygen atoms. So sp3 hybridization. So one lone pair and 3 bond pairs. Therefore geometry will be pyramidal like ammonia. Next, XeOF4. XeOF4. So central atom Xe undergoes sp3d2 hybridization. So here one lone pair plus 5 bond pairs. Therefore according to Vesper theory, square pyramidal geometry. This is lone pair and remaining are bond pairs. So XeO3 pyramidal, XeOF4 xenon oxy tetrafluoride, square pyramidal. Therefore option B. Next. So group 16 elements are also known as, group 16 is nothing but 6th A group. These are known as chalcogens, that means ore forming elements. Most of the ores will contain these elements only. Therefore option D, chalcogens. Next. Here in the following reaction, A, B, P, Q, R, S respectively are. So this is balanced equation between XeF4 and H2O. It will form Xe, XeO3, HF and O2. So after balancing, we will get A6, B12, P4, Q2, R24, S3. So remember, XeO3 xenon trioxide is hygroscopic and explosive, highly explosive. Hygroscopic means this compound can absorb water vapor from atmosphere. So by observing these stoichiometric coefficients, option will be C, 6, 12, 4, 2, 24, 3. Stoichiometric coefficients. Next. The correct decreasing order of following xenon compounds to act as both fluorinating and oxidizing agents is. So XeF6, XeF4, XeF2. So here maximum oxidation state of any element can represent its oxidizing nature. That means as the oxidation state increases, oxidizing nature also increases. So here XeF6 has plus 6 oxidation state, XeF4 plus 4, XeF2 plus 2. Therefore, oxidizing nature and fluorinating nature will be in this order. XeF6 highest, XeF2 least, XeF4 is intermediate. Therefore, option D. Next. So here the main products P and Q are the following unbalanced disproportionation reaction. SeCl2, selenium dichloride. So selenium dichloride undergoes disproportionation to form selenium tetrachloride and selenium. So here Se plus 2 state, Se plus 4 state, Se 0. So plus 2 to plus 4, which is oxidation, plus 2 to 0, which is reduction. So the same substance undergoes both oxidation and reduction simultaneously. Therefore, this is disproportionation reaction. So P is SeCl4 tetrachloride and Q is Se selenium, elemental selenium. Option C. Next. Linear molecule among the following is linear molecule among the following. Here SnCl2, bent shape with 2 bond pairs, 1 lone pair, bent. PbCl2 similar, 1 lone pair, 2 bond pairs, bent geometry, bent or angular or V shape. Next, SO2 similarly bent with 1 lone pair. Next, XeF2, so 3 lone pairs and 2 bond pairs, linear geometry. So here remember hybridization of Xe, sp3d. So here 2 bond pairs, 3 lone pairs. Very, very important. Linear geometry. Therefore, option D. Next. The correct order of boiling points of H2O, H2S, H2SE, H2TE are. So, boiling point directly proportional to molecular weight. As the molecular weight increases, boiling point also increases due to increase of van der Waals force of attraction. So, therefore, order should be like this. H2TE, H2SE, H2S and H2. This order is expected. Expected according to molecular weight. Molecular weight decreases in this order. Therefore, boiling point decreases in this order. So, H2TE will be having highest boiling point. But here in H2O, due to the presence of intermolecular hydrogen bonding, boiling point will be maximum. Therefore, order will be first H2O, next H2TE, H2SE and H2S. So due to intermolecular hydrogen bonding, it will be having highest boiling point. Therefore, order D. H2O highest, H2S least. So H2S is having lowest boiling point. Therefore, it is highly volatile. Highly volatile. That means becomes vapor easily. Very, very important question. Next. The element that even can diffuse through silica glass is. So, this is helium. Helium has lowest molecular weight. So, here molecular weight we know 4. molecular weight 4. So rate of diffusion inversely proportional to square root of density or square root of molecular weight. So as the molecular weight decreases, that means as the molecular weight decreases, diffusion increases. Therefore, helium even can diffuse through silica glass. So here option A, here it is given wrong. Option A. Which is helium. So due to lowest molecular weight, it can diffuse easily. Helium. That is based on rate of diffusion. As the molecular weight decreases, rate of diffusion increases, inversely proportional. Next. Sulfur dioxide reacts with chlorine in the presence of charcoal to give. Charcoal means nothing but carbon form. Here SO2, sulfur dioxide, reacts with Cl2 gas in the presence of charcoal to form SO2 Cl2. It is addition compound. Addition compound. So very, very important, which is sulfuryl chloride. Sulfuryl chloride, addition compound. So clearly option C. Addition compound of SO2 and Cl2. Next. Sulfur on boiling with NaOH solution forms. So sulfur on boiling with NaOH solution. Sulfur with NaOH. It will give Na2S2O3, sodium thiosulfate plus Na2S plus H2O. So after balancing here 4S, 6 NaOH, next here 2 Na2S and 3 H2O. So sulfur oxidation state here 0. Next here plus 2 for each sulfur, here minus 2. So 0, 2 plus 2, 0, 2 plus 2 and again 0, 2 minus 2. So 0, 2 plus 2 oxidation, increase in oxidation state, and 0, 2 minus 2 decrease in oxidation state, reduction. So therefore the same substance undergoes both oxidation and reduction simultaneously. Therefore this is best example for disproportionation reaction. Disproportionation. Very, very important. Disproportionation. So option A. Sodium thiosulfate and sodium sulfide will be formed. Next. Small quantities of NO and HNO3 are formed as impurities when N2 is prepared from NH4Cl and Na2O2. So these impurities can be removed by passing N2 gas through which of the following? Check here. N2 gas is prepared from. So check here. It is given that in the preparation of N2 from NH4Cl and NaNO2, NO and HNO3 are formed as impurities. These can be removed. First I will write preparation. So NH4Cl plus NaNO2, ammonium chloride and sodium nitrate. First it gives NH4NO2 plus NaCl. So which on heating gives N2 plus 2H2. This is the preparation. N2 gas will be formed. So this is most important preparation of N2 from ammonium chloride and sodium nitrate. Here the formed compound is, this compound is ammonium nitrate, which on heating gives N2 gas with release of H2. So your impurities NO and HNO3 are removed by using K2Cr2O7 potassium dichromate with concentrated H2SO4 or aqueous H2SO4, which is known as chromic acid, powerful oxidizing agent. So that can remove almost all impurities, which is known as chromic acid. Chromic acid, H2CrO4, that removes all the impurities. Therefore, option B, K2Cr2O7 potassium dichromate in the presence of H2SO1. This will be known as acidified potassium dichromate. Acidified K2Cr2O7, powerful oxidizing agent. Option B. Next. The moisture present in ammonia can be removed by using moisture present in ammonia can be removed by passing. Next. So for drying ammonia gas, CaO quicklime can be used because CaO does not react with NH3 gas. Remaining compounds P4O10, concentrated H2SO4 and CaCl2 can react with ammonia gas. Therefore, CaO can be used to dry ammonia. Therefore, option D. Here there is no combination between CaO and NH3. Therefore, it can be used. So, remaining options A, B, C can react with ammonia. Therefore, they cannot be used. Next. The element with highest electronegativity value after fluorine is. So, on Pauling scale of electronegativity, highest electronegativity possessed by fluorine. After that, 3.5 oxygen. Next, nitrogen and chlorine value 3. Next, carbon and sulfur 2.5. Hydrogen and phosphorus 2.1. Remember these values. So first highest fluorine. After that, second element is oxygen. That is B, 3.5 on Pauling scale. Next question. In the reaction of phosphorus with concentrated HNO3, the oxidized and reduced products respectively are. So phosphorus P4, white phosphorus, reacts with concentrated HNO3 to form H3PO4, which is orthophosphoric acid, plus NO2 plus H2O. So after balancing here 20 moles, next here 4 moles, here 20 moles, and here 4 moles. This is the balanced equation. So here P4 oxidation state 0, and here P plus 5, and here plus 4. Next, that means the compounds are phosphoric acid, and this one nitrogen dioxide. So for nitrogen here plus 5 oxidation state. Next I will write this one. So P4 0 to plus 5. This is increase in oxidation state. Oxidation, and next HNO3 to NO2. So plus 5 to plus 4, decrease in oxidation state, which is reduction. So both are taking place in same reaction. Therefore, this is best example for redox reaction. So H3PO4 and NO2 will be formed. That is option A. Next. So what are X and Y in the following reaction? So Pb3O4, which is red lead oxide. Red lead oxide gives PbO plus O2. So take here 2 moles. Next, here 6 moles. So balance equation. Next, lead monoxide. Lead monoxide and oxygen gas. So which is known as litharge. So check here. Option X. So therefore X is 2 and Y is 6. 2, 6. Option D. Red lead oxide will be converted to litharge with release of O2. So in preparation of O2, this reaction can be used. Next. Among the following, the least covalent in nature. Least covalent. That means nitrogen, phosphorus, arsenic, antimony, and bismuth. So in this direction, that means top to bottom, metallic nature increases. So due to increase of size. Size are also same. So as the size of cation increases, ionic nature increases. That means large cation plus small anion can form ionic bond. Remember this point. Large cation and a small anion can form ionic bond. Therefore, so here BiF3. So Bi3 plus is large cation and F minus small anion. So therefore, it will be ionic. Therefore, least covalent. Option B. It can form ionic bond. Next question. So in the following reaction, the products X and Y respectively are reaction between I2 and Cl2 in the presence of, that means in aqueous solution simply. So I2 plus Cl2 plus H2O, it will give HiO3 plus HCl. So after balancing 5Cl2, 6H2O, 2HaO3 and 10HCl. So here I2 iodine, Cl2 chlorine. So HiO3 iodic acid and hydrochloric acid. So HiO3 and HCl will be formed. Option C. So here iodine oxidation state 0, Cl2 also 0. Here I oxidation state plus 5 and Cl oxidation state minus 1. So iodine is oxidized and Cl2 is reduced. Redox reaction. I will write like this. Here I2 to HaO3 increase in oxidation state, therefore oxidation. Next Cl2 to HCl decrease in oxidation state, reduction. Therefore best example for redox. Option C. Next, match the following compounds with corresponding physical properties. They are just colors. So for A compound, so A is IBr. So IBr will be black solid. This is only physical property, that is 3. Next B, ClF3, colorless. Option 4. Next C, yellow green liquid. So second one, colorless gas. Green, yellow liquid. So which is 2. Last D, ICl3 is orange solid. That is 1. So 3, 4, 2, 1. Option C. Just it is only colors, physical property. So all these are interhalogen compounds. Interhalogen compounds. Very, very important. Next. Tincture of iodine is the common name for tincture of iodine. So tincture of iodine is, so most important, so 2 to 3% of I2 along with some amount of potassium iodide or sodium iodide in ethanol and water. So this mixture can be used as antiseptic. Antiseptic, very important. So tincture of iodine is I2 plus Ki or I2 plus NaI in ethanol and water mixture. This can be used as antiseptic. Option C. Next. So number of different bonds present in P4O10. So P4O10 can be written as, so first write P4 like this. Next in between two phosphorus atoms O, case-like structure. So after that, next double bond O, double bond O, double bond O and double bond O. Check. Case-like structure. Now count the number of bonds, types of bonds. PO bonds and P double bond O. P single bond O's and P double bond O's. So number of PO single bonds equal to how many? Single bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Next number of P double bond equal to 4. So two types of bonds, P single bond O's and P double bond O's. So 12 and 4. Option C. Case-like structure. Next. So which one of the following statement is not correct regarding phosphine? Phosphine. That is pH3. Phosphine gas formula pH3. So it is weak base due to lone pair. Weak Lewis base due to the presence of one lone pair on phosphorus. So it is weak base, correct. It reacts with CuSO4 to form, see here, CuSO4 copper sulfate reacts with phosphine gas to form Cu3P2 plus H2SO4. So after balancing 3 and here 2 and here again 3. So which forms cupric phosphide. Cupric phosphide, so which is black PPT. It will be formed when phosphine reacts with copper sulfate. So therefore B is wrong, not correct. So it is formed by, next option C, it is formed by reaction of Ca3P2 with dilute HCl. On hydrolysis it will be released CaCl2 and pH3. That is preparation. Next, it is used in smoke screens. So in smoke screens, combination of Ca3P2 and CaC2 mixture can be used. Very important. So option B is incorrect. Next. So which are the following does not exist? So XeO4, XeOF4, xenon oxytetrafluoride, that is possible. XeF2, xenon difluoride, that is also possible. XeF6, hexafluoride, that is also possible. NeF2, not possible. Neon cannot form bonds with fluorine due to high ionization energy. Very, very important. But xenon can form bonds with fluorine and oxygen due to very low ionization energy. Very, very important. Therefore, B not possible. So due to low ionization energy, it can form bonds with more electronegative elements, like these two are more electronegative elements. Xenon forms compounds with only these two elements. Next. So which one of the following oxo acids of phosphorus can reduce AgNO3 to metallic silver? So here AgNO3 to metallic silver means Az. So here Az will be in +1 state, here Az 0. So this process is reduction. So for this process, reducing agent is required. So here H3PO2, take H3PO2, that acts as reducing agent. Very, very important. Reducing agent due to pH bonds. pH bonds are responsible for reducing property. So double bond O, here H, and here H, and here OH. So more number of pH bonds are present. Therefore, it is reducing agent. Option A. Next. SF6 is highly stable due to spherical geometry. SF6. So very, very important example. SF6. Highly symmetrical molecule. Symmetrical structure. Therefore, highly stable. Spherical geometry. Next. SF6 is a gas. Due to low surface area, so van der Waals forces will be weak. Therefore, that exists in gaseous phase. So both are correct, but not correct explanation. So due to weak van der Waals force, it will exist in gas phase. Option B. So SF6 is highly stable due to symmetrical structure. Spherically symmetrical. And it is gas due to weak van der Waals force. Next. So pair of amphoteric oxides. Amphoteric oxides. So here Al2O3, amphoteric. Li2O, basic. B2O3, acidic. MgO also basic. Next BeO and ZnO, amphoteric. So check here clearly D option. BeO amphoteric and ZnO also amphoteric. Next. Which noble gas has least tendency to form compounds? So among noble gases, helium and neon will be having highest ionization energy. Between these two, helium has highest first ionization energy in total periodic table. So due to highest ionization energy, it cannot form. That means has least tendency to form compounds. Very important point. C. Very high amount of ionization energy. A colorless neutral paramagnetic oxide of nitrogen P on oxidation gives reddish brown gas Q. Q on cooling gives colorless gas R. Next, S on reaction with P gives blue solid. Here not S, it should be, let me check once. Q on reaction with colorless gas R. S on reaction with gives blue solid S. This is not S. Q. It should be Q. Q on reaction with P gives blue solid S. Identify P, Q, R, S. So simple reaction only. So first colorless neutral gas, which is NO. Colorless, neutral and paramagnetic due to odd number of electrons. NO on oxidation 2NO plus O2. This is P gives 2NO2, which is Q. This one colorless. Next NO2, reddish brown gas. This is colorless gas, reddish brown gas. Next, Q on reaction with P gives blue solid. Next, one more point is that Q on cooling gives, on cooling, it will be converted to N2O4. N2O4, which is R, dinitrogen tetroxide. Next, R on reaction with P. Here R should be there. R on reaction with, here R is N2O4 that reacts with, again, 2NO. NO is here P to form 2N2O3, which is S. Blue solid. Very important. So dinitrogen trioxide or nitrogen sesquioxide. So here once again. So colorless neutral paramagnetic gas NO reacts with O2 to form NO2, which is reddish brown, that is Q. NO is P, NO2 is Q. So which on cooling gives N2O4. N2O4 colorless gas. That on reaction with P or on reaction with P gives blue solid N2O3. Dinitrogen trioxide or nitrogen sesquioxide. So here P is NO, Q is NO2, R is N2O4 and S is N2O3. So option C. Next question. Which are the following properties true for the following sequence? So given sequence is NH3, PH3, ASH3, SbH3 and BiH3. These are hydrates of group 15 or 50A hydrates. So decreasing order is given. So decreasing order. So here thermal stability represents this order. Thermal stability. Thermal stability. Or we can write Lewis basic nature also. Lewis basic nature decreases down the group. Lewis basic nature. But here in options, thermal stability only is given. Therefore, thermal stability. These are hydrates of group 15 or 58. Nitrogen to bismuth decreases. Thermal stability decreases as well as Lewis basic nature also decreases. NH3 is most basic. Therefore, that can form complexes very easily. So, this is the end of the chapter. In next video, I will explain one more chapter. All the best and thank you.